I'm going to show you how to add together vectors using components. I have vector A, which is 55 degrees from the negative x-axis, and vector B, which is 30 degrees from the positive x-axis. The first thing I'm going to have to do is break it into components. I will use the red arrow to show the components of the vectors. Vector A will have an x component, showing how much of that vector is oriented in the x direction, and a y component, showing how much of that vector is oriented in the y direction. Vector B will also have bx and by. In order to add the components, I need to determine the directions of each of these vectors. So let me identify that first. The vector itself does not have a positive or negative direction, but each of its components does. AX is pointed to the left, which in our right-handed coordinate system is considered to be negative, so I'm going to put a negative sign in front of the AX. AY is pointed up, which in our right-handed coordinate system is considered positive, so I'll put a positive sign in front of the AX. I can follow the same process with BX and BY. BX is pointed to the right, which is considered positive, and BY is pointed up, which is considered positive. Now that I have their orientations identified, I need to use some right triangle relationships to determine their relative lengths. The hypotenuse of vector A is 15 meters, so to determine side AY, I'm going to use trigonometric relationships and say the sine of 55 equals the opposite, which is AY, divided by the hypotenuse, which is 15. I can do the same thing for side AX using the cosine. 55 equals the adjacent side, which is AX, divided by 15. I will repeat the same process for the second vector. Now I have all four of my components. I need to indicate, and both of these are positive. Bx is positive and by is positive, as we saw before. Now I'm going to add my x components together to find the total x component of my resultant. And I'm going to give myself a little more space for this. So I add ax plus bx, which are negative 8.6 plus 5, which equals 13, which equals negative 3.6. Make that large enough for you to see. Then I will add my y components. So ay plus by equals positive 12.28 plus 1, which equals 13.28. Also make that large enough so you can see it. Once I have my total x component, which is 3.6, negative 3.6, my total y component, which is 3.28, I'm going to draw my final triangle. Negative x goes to the right, positive y goes up, so my resultant vector, which I will draw in red, will be in the second quadrant. This side will be 3.6. When we do the Pythagorean theorem, we do not include the negative sign because the value is indicating the size of that side, not the orientation. The arrowhead is indicating the orientation. So this side is 3.6, this side is 13.8, and to find the size of the resultant, I will use Pythagorean theorem. So 13.8 squared plus 3.6 squared equals, which equals 192. Make that large enough so you can see it. Right over here. And of course, to find the hypotenuse, we have to take the square root of that, and the square root is equal to 13.8. So our hypotenuse is 13.8. And to find our angle, since we did not draw these to scale, we can't use our protractor this time, we will do the inverse tangent. So the inverse tangent is written tan to the minus 1 of our angle x equals opposite. I'm going to find this angle right here between the axis and the tail of the vector. So the opposite is 13.38 divided by the adjacent, which is 3.6. Is that large enough to read? And that answer is 75 degrees. And that indicates the angle right here. So our final answer is a vector 13.8 meters long at an angle of 75 degrees to the negative x-axis. If we go back to the original diagram and compare it, now if I take my vectors, and these are not drawn to scale, but roughly we can look and see what we would get as a resultant vector. Probably need to make this one longer since this one is 15. I'm drawing my resultant. I get something in the second quadrant at that orientation and between the lengths of the two vectors.